Hi guys, as I mentioned in the blog, this is going to be a proof of concept for Versatile. But before we begin, I want to make some aclarations. The first one is that this proof of concept will cover just how the UI and the data interact. It won't cover the comment system or the metadata or, for example, the versatility of the UI. I'm just going to cover these two specific elements because I consider them the most essential part of any social network. The second acceleration that I want to make is that you'll need to install some dependencies in order to run this code. For example, IPFS implementation for Python, a pcryptodome, and also Tkinter. I had some problems installing these dependencies directly on my PC, so I used a virtual environment and I highly recommend you to do the same. Also, I wrote this code on Python 2.7, so make sure you have that version installed. And also, I wrote this code on Linux. So, for example, I used Liberation Sans for the UI. I don't know if this could cause you any problem if you're using Windows or Mac, but I highly recommend you to change it directly on the code or to pre-install the font before you try to use the UI. So that's all for the moment, and let's begin. Now, here I have the code, both files that I uploaded to GitLab. And also, I have my virtual machine that is going to represent the person that I'm going to interact with. Let's call her Alice. And now I'm going to start IPFS in bot. Enable poop sub experiment. Okay, remember to enable the poop sub feature. If not, you're not going to be able to use this in the right way. Poop sub experiment. Right. Now I'm going to open the UI. Okay, here is. As you can see, you have the hash, the public key, the for the private key, the sign in button, etc. And I'm going to do the same here. Sorry. My virtual machine is a little bit slow. Something that I want you to notice is, for example, here the entries have a different size from, for example, here. And that's because, for some reason, Tkinter changed the look depending on which operating system you're using, or even which computer you're using it. So I hope that you can understand, that if it looks different in your PC, it's because of that reason. Okay, now what I'm going to do is I'm going to register. Okay, here you can see that I have a hash. This is because when you register, the GUI automatically creates a new JSON file that is automatically uploaded to IPFS. And this JSON file contains the first block on the blockchain that has a default message when it is created and with a default hash. I'm going to show you how this works in detail in a moment. Now here you can see that we have the private key and the public key. Now this is very important. This is the hash of the public key. I used SHA-1 to hash it because it's easier to read and to type, and this is supposed to be the identifier of the account. This is supposed to be used as a topic in IPFS PubSub, where you publish the hashes of your of the blockchain. And now here I'm going to register also. You can see that it gives you also a hash, and this is the same data as before. Okay. Now what I'm going to do is I'm going to copy all this data in a new text file, and this is because I want to share this with other PC. Also, the public key and the private key. This is going to be necessary for um, when you want to add a new friend, and also because I want to show you that you can access the account from any computer. So I'm going to copy of this data. Here I'm going to do the same. Okay, it's done. Right. Now I'm going to continue, and you can see this is the UI. You know, this is your wall where all the publications appear, etc. And this is very important. Here says welcome to Versatile. This is the default message in the blockchain. As you can see, here is the public key and the private key, and also the publications JSON. And this is the blockchain. You know, it has the index, the hash, the encryption, signature timestamp, data, etc. And this is the data, the default data that is created when you register in the social network. And now I'm going to do the same. Okay, and here is exactly the same message, the timestamp, and also I want to show you that the same files were created here. You know, the public and the private key, and also it is exactly the same default block. Okay, so I want to publish something now to show you how this works. So for example, I want to publish hello world. Great. You can see the data and the timestamp, and if I update it, you can see that it is added to the blockchain. Okay. Now, as you can see, a new block was created. You know, the hashes are the same, and okay, and this is very important. This is the hash because what happens is that when you create a new block or when you publish something, the previous JSON is replaced with a new one, and that one is uploaded to IPFS automatically. So people can always find the latest file. So I'm going to publish something different. For example, using Versatile publish. You can see it is updated, and there is a new hash now, and a new block is created. Okay, okay. I'm going to do the same here. Uh, for example, I I'm Alice. Okay, and you can see here is also updated. Here is also a new hash, and let's publish something else. Mm, Okay, and it's updated. Okay, there's a new hash. No, what I'm going to do is I'm going to share the files with the keys. Um, I'll see you in a moment. Okay, here are the files. And what I'm going to do is I'm going to add a new friend. So, for example, what we want to do right now is interact with other people. We want to interact with Alice, for example, and Alice wants to interact with me. So I have here the files and all the data, and I'm going to show you how it's supposed that you should add a new friend here. So you can see here is a button, to add a new friend, and you add the friend's name, the hash of his JSON, and his public key. Now, so for example, if I enter something that is wrong, it won't let me, to do it. It will tell me that the hash is not found. And so I'm going to write her name. You can call your friend whatever you want. In this case, is Alice. It's, for example, what I mentioned in the blog about that kind of versatility. And to add the hash, what I'm going to do is I'm going to sub input sub to his unique identifier. Sub. Okay. Now I want to make a specific acceleration. All this process, about the hashes and about pub subbing and that kind of stuff, should be done automatically by the GUI. But because the Python implementation of IPFS still has not pub sub built on it, I need to do this process manually. But the idea is that automatically the GUI should hash the public key when you enter it, and should sub to that topic on PubSub, and also it should publish automatically in your own topic when you register or when you publish something. Okay, here I'm going to do exactly the same. Okay, now I'm going to share the hash of my publications. It's done. So now it should be here. Yes, okay. This is the hash. I'm going to copy it, and I'm going to paste it here. Okay. And now Alice is here, and it shows me her publications. Okay. I'm going to do exactly the same, but now with the hash of my publications. Okay. Mm, it's here. I'm going to repeat the process. Something that I forgot to mention is that you need the public key to encrypt a message if you want to send it to someone else, and also because it is needed to verify that every publication in the blog was done by that person. I'm going to explain this in a minute, and also there is an explanation in the code, but I want to make clear that it is also the identifier of your account in some sense because it is hashed. Okay, and you can see that here is everything that I published. Great. So now I am going to um, I am going to publish something else. For example, I'm publishing a publish. Okay, I here I had a problem with the key term, but you can see that it was published. And if I update it, you can see it here. And now if I want to update it, I just need to add the hash of the last JSON. Okay, okay. Now the hash is added to the topic. I'm going to copy and paste it here, and you can see the publications are updated. Now I want to show you what happens when you update the publications, because when you publish something, that block is assigned when you with your private key, and when someone else updates your publications, your JSON, then with your public key, they verify that every block is exactly the same that you published, and if that block is not the same, or it was modified, or for example, if the public key doesn't match with the private key, then the UI automatically ignores that block. So you can see that here it takes the hash, it also verifies the signature, and if not, it just pass the block. Now I want to show you how is that you send an encrypted message to your friends. So I'm going to publish something different. Okay? And then I'm going to encrypt it. And here it asks you for the name of the friend you want to send a message. And this happens because the UI automatically saves the key of your friend when you add it. I'm going to show you here. There is a part where there is a dictionary where all the keys are saved. Uh, Here you can see that it says friends keys ticked, and here all the keys with the name that you gave to your friend are saved. All lists you can see the message here, but if I go here, you can see that the UI doesn't show me the message. And this is because the UI will only display the message if your private key can decrypt it. And because I don't have the private key of Alice, the UI will only show that message. I'm going to share this file with Alice. Okay, I'm going to use this hash. Okay, and you can see that because I have the private key and my private key is able to decrypt the message, it shows to me and says that it's only for me or that the message was encrypted. I'm going to do exactly the same process, but no for me. Okay, here's the message. The GUI doesn't show it. Now I'm going to share it with myself. Okay, I put the hash, and now it says exactly the same. It shows me the message. And the last thing that I want to show you is how you can access to your account from different PCs. For example, I'm going to access Ali's account from my computer. So what I'm going to do is I'm going to enter the hash of the last publications that I had. Is is this one? I'm going to ignore the other one because that's a mistake that I made. And again, this shouldn't be necessary because if you put your public key and your private key, then automatically the UI should retrieve the content from the topic on IPFS. But because it is not implemented in Python yet, I need to do this whole process manually. Sign in, and here are all the publications of Alice, as you can see. I'm going to do exactly the same here, and I'm going to access my main account from Alice PC. Okay, I'm going to sign in, and here you can see all my publications are here. When you try to access your account, what happens is that first the UI retrieves the content from IPFS, then it looks at the first block and hashes the block and signs it with a public key that you gave to it. Then that signature is compared to the actual signature of the block, and that is to verify that the block on the general blockchain wasn't changed. And so here you can see that first it tries to verify that are actually RSA keys. And here it takes the data from the block, from the first block, and now it takes the signature and tries to verify the signature with the public key that you gave to it. Then it tries to compare that signature with the one that is created, with the new one. Then, if they don't match, the UI interpret that as an alteration in the block. And this is to add an extra layer of security uh, when you try to access to your account. And it also verifies that the public key and the private key matches. And here you can see that if the verification is true, then it tries to assert if the original signature and the newly generated signature are the same. And if that happens, then it tries to access or to create a main window and gives you access to your publications and to your account. Thank you guys. I highly recommend you to read the whole post, and if you have any idea or any doubt or any criticisms to what I posted or the code or even about this video, please let me know in the comment section here or in Reddit or maybe on the blog, and maybe we could discuss it there. Also, I encourage you to try the code by yourselves, and I hope this video was helpful to you.